Hello, this is Mr. Stansbury. I'm going to take you through the notes on solutions of quadratic equations. At the end of this, you should be able to say, I can use the discriminant to determine the nature of the solutions of a quadratic equation. Okay, so here's what we're going to take a look at here. An example, solve the equation using the quadratic formula. Write, after that, 1, write the number of solutions. 2, are the solutions real or complex? And then 3, if real solutions, are they rational or irrational? So I know that's a lot to think about it, so let's just kind of take care of one thing at a time. Let's just solve this using the quadratic formula. Okay, so in this case here, A equals 4, B is 5, C is negative 2. So if we're going to plug that thing in, we get X equals negative B, which is 5, plus or minus square root of B, which is 5 squared, minus 4 times A is 4, times C is negative 2, all over 2 times A, which is 4. Okay, so we're just plugging stuff into the quadratic. So on that, we get X equals negative 5, plus or minus 5 squared is 25. Negative times a negative is a positive. 4 times 4 is 16, times 2 is 32. All over 2 times 4 is 8. So we get X equals negative 5 plus or minus square root of 25 and 32 is 57. All over 8. Okay, so those are our two solutions. So we did the first things we solved using the quadratic formula. Now we're going to write the number of solutions. So we got negative 5 plus root 57 over 8 and negative 5 minus root 57 over 8. So there are, for part 1, there are 2 solutions. Let's see, for the part 2 says, are the solutions real or complex? So remember, complex means it has to have some kind of imaginary number, so that basically means that has to have a negative in there. So that does not. So it's let's see, it says, are they real or complex? So these are real solutions. And then the third part says, if real solutions, are they rational or irrational? So since this root 57 is not a perfect square, that means that they are irrational. Irrational solutions. Okay? Okay, so that's the 3 things. So not as bad as it originally looked, I hope. Okay, so for part B, let's do this thing again. This is just good practice. So we get A is 4, B is 4, C is 5, right? And then we're going to plug it into the quadratic. X equals negative B, which is 4, plus or minus the square root of B, which again is 4, squared, minus 4 times A, which is 4, times C, which is 5, all over 2 times A, which is 4. Okay, lots of 4's in there. And then 1, 5. So anyway, simplify this. X equals negative 4 plus or minus. And now we got the square root of 4 squared is 16. A negative times a positive is a negative. Let's do this. 4 times 5 is 20. 20 times 4 is 80. So we get minus 80. All over 2 times 4 is 8. So we get X equals negative 4 plus or minus the square root of 16 minus 80 is going to be, let's see, what's that going to give us? 44? Negative 44? No, negative 64. What am I talking about? 74, yeah, that would give us negative 64 all over 8. So this actually gives us X equals negative 4 plus or minus. Remember, this negative 64 turns into square root of negative 1 times the square root of 64. That negative 1 is I. The 64 is actually a perfect square, so that's an 8. So this is going to be negative 4 plus or minus 8I all over 8. We could simplify this some And maybe we probably should, especially since we're first learning out how to just look at all the 4, the 8, and the 8. As long as it's not inside the radical, you can simplify them together. So those are all divisible by 4. So really we get x equals -1 plus or minus, if we divide all these by 4, 2I over 2. Okay? So that's our solution. So now it's asking what kind of, how many solutions are there? So we get -1 plus or minus 2I over 2. So that's going to be 2 solutions. Part 2 says what kind of solutions are these? These are going to actually be, they're not going to be real, right? They're going to be complex. That's because we had a negative under the square root. And then 3, it says, if it's real, are they rational or irrational? So we don't have to answer number 3 because it wasn't real, it was complex instead. Okay? Okay, that's how to do these. Now, there's actually a way that we can figure out the answer to these 3 things here without doing all of this, by just doing a little part of that. So we're going to take a look at that, but first, let's take a quick little comedy break.
5-year-old boy holding a helium balloon. And he accidentally let go of his balloon. The boy started crying, and his parents were like, "Why are you crying? It's a balloon. We'll get you another one." I'm like, "Japers, grapers, folks." Sometimes I don't think adults try hard enough, to understand what kids are going through. If you wanted to relate to what he's going through, imagine if you took your wallet out and it just started floating away. Why are you acting like that? It's a wallet. We'll get you another one. I want that one!
All right. So let's take a look here. We're going to actually do this. There's this thing under the root here, the b squared minus 4ac. This is called the discriminant. Okay? And this is going to determine the number of solutions that we're going to have. It's also going to determine, are the solutions real or complex, and also it's going to, if it is real, we can say if they're rational or irrational just by looking at what we get under here, the discriminant. Okay, so again, the discriminant is b squared minus 4ac. That's our discriminant. Okay, so if the discriminant d is greater than 0, so if whatever we get under the root here, bring this stuff back up here, and I'm going to circle our discriminant. So on this one here, our discriminant ended up being 57, and on this one, our discriminant ended up being -64. Okay? So if the discriminant is greater than 0, this one right here, and it's a perfect square, which it's not, then, but let's say if this was a perfect square, let's say if this was square root of 4, then this would have given us -5 plus or minus 2 all over 8. These are all going to be rational numbers, right? They're all going to be, it's all going to be rational. So if d is greater than 0 and it's a perfect square, this number underneath here, then that means it's going to have 2, let's do this in a different color so we can see it better. We're going to have 2 solutions. Okay. And so 2 solutions. If it's a perfect square, then part 2 says, are the solutions real or complex? So they're going to be real. And if they're real, are they rational or irrational? So since it's a perfect square, these are going to actually be rational. Okay. If d is if the discriminant, this number here, is greater than 0, but not a perfect square, just like this right here, we're going to have 2 solutions. Oh, golly, I'm having a hard time. Hold on. 2 solutions. They are still going to be real, right? Okay, they're going to be real. But then they're going to be irrational because it's not a perfect square. Okay? Now, if this d here happened to equal 0, so if this number here was 0, let's pretend this one right here is 0, we get -4 plus or minus 0. So that plus or minus 0 doesn't do anything. It's just -4 over 8, which would give us negative 1/2. So that means that there's just one solution. Okay, and it's going to be, in this case here, it's going to be real. It's going to be a real number there. And there's also, it's going to be rational, because it's just going to be like a fraction of some sort. Okay, so one solution, real, rational. That's if if this number under the radical happens to equal 0. Okay, and then if d is less than 0, like this one here, that means it's negative, some kind of negative number. There's going to be two solutions. All right, and then it's not going to be real, but it's going to be complex. And then we don't have to say if it's rational or irrational because it's complex. Okay, and so this here can be kind of a nice little key for us to figure out what this is helping us use the discriminant to determine the nature of the solutions of a quadratic equation. So this here is going to be fairly useful to us. Okay, so we're going to actually use this on a few other examples here, and we're going to call it good. Okay, so we're going to take a look at these examples here. We're going to use the discriminant to determine the nature and number of solutions here. Okay, so here's our discriminant, b squared minus 4ac. So this one here, a is 4, b is 5, c is negative 2. Once in a while, they'll rearrange these. You just got to make sure that whatever the x squared is, that's your a, whatever the x is, that's your b, and whatever the number without an x on it is going to be your c. But I think for most of these in here, we're not going to try to mix those up. But once in a while, eventually you'll see it mixed up a little bit. Anyway, on this one here, b squared is 5, so we do 5 squared minus 4 times a, which is 4, times c, which is negative 2. So 5 squared is 25. Negative times a negative is a positive. 4 times 4 is 16, times 2 is 32. So that's 57. Okay, so we get... we're going to end up having, this will end up being the square root of 57. So the d is greater than 0, and it's not a perfect square. So that means that this one here is going to have two solutions, and they're going to be real solutions, and they're going to be irrational. Okay, just by looking at the discriminant. Okay, hopefully you can kind of see where this can come in a little bit handy instead of taking it through the entire quadratic equation. This one here, a is 4, b is 4, c is 1. So we get, for the discriminant, we get 4 squared minus 4 times 4 times 1. So 4 squared is 16. Negative times a positive is a negative. 4 times 4 is 16. Times 1 is 16. So this actually gives us 0. So that's going to be this case right here. D equals 0, 1. There's going to be one solution, right? Because you're going to have plus or minus 0, which doesn't matter with the plus or minus. So you're just going to get one solution. It's going to be real, a real solution, and it's going to be rational as well. Okay? E, a is 4, b is 4, c is 5. So we get b squared, which is 4 squared, minus 4 times a, which is 4, times c, which is 5. So this is 16. Negative times a positive is a negative. 4 times 4 is, let's do this. 4 times 5 is 20, times negative 4 is negative 80. So this gives us, sorry, that's square root of 0, which is 0. This gives us square root of negative 64, right? So this is where d is less than 0. So that means for this one here, you're going to have two solutions. And it's going to be, they're going to be complex solutions. Okay, and you'll have to write if they're rational or irrational because it's complex. Okay, and then last one here, F. A is 4, B is 5, C is negative 6. So we get B, which is 5 squared, minus 4 times A, which is 4, times C, which is negative 6. 5 squared is 25. A negative times a negative is a positive. 4 times 4 is 16. 16 times 6 gives us 96. So then we take 96 plus 25, and we get 121. Now the thing is, if you take the square root of 121, that gives you 11, right? So the discriminant is greater than 0. It's one of these two, and it's a perfect square. That means we have two solutions. They are real solutions, and it is a rational solution because it's just going to end up being some kind of fraction over another two fractions over. Our answers are going to end up being two fractions without any roots in it anywhere because our square root was perfect. Okay? Okay, that's all we have for solutions of quadratic equations. If you have any further questions, please feel free to ask in class. Thanks.